So as we continue to look at some different things involving significance tests with quantitative data, the next thing we're going to get into looking at is some different things with two-sided significance tests and the relationship that they have to confidence intervals. So an example here says, at the Hawaii Pineapple Company, managers are interested in the sizes of the pineapples grown in the company's fields. Last year, the mean weight of the pineapples harvested from one large field was 31 ounces. A new irrigation system was installed in this field after the growing season. Managers wonder whether this change will affect the mean weight of the future pineapples grown in the field. So just note here they're saying they want to know if it will affect it. It doesn't say whether they think it's going to be more or less than. To find out, they select and weigh a random sample of 50 pineapples from this year's crop. So they have the summary of the data below here. So it gives you the sample size, the sample mean, the standard error of the mean, the standard deviation, and then here is the 5-number summary: minimum, Q1, median, maximum, Q3. And first it says to determine whether there are any outliers. So just remember, when you're talking about 5-number summary and determining outliers, you're talking about the 1.5 times the interquartile range rule. So when I go to compute the interquartile range here, I'm going to do Q3 minus Q1, which comes out to be 41.125. And if I multiply that by 1.5 and I subtract it from Q1 and add it to Q3, I end up with these values here: 40.3025 and 23.0825. So anything that falls either above this number or below this number, we're going to consider those values to be outliers. So if you look up top here at the table, we have a minimum of 26.491 and a maximum of 35.547. So since neither one of those values fall above or below these two indicated values, then it would be safe to say that in this particular instance, that mathematically speaking, there are no outliers to this random sample of 50 pineapples. So if I was to continue with a significance test for this, and just kind of throwing this out there as once again in sort of that state, plan, do, conclude type format. So in the state part, I want to mention first what the null and alternative hypothesis is. So with this one here, the null hypothesis is that the average weight of the pineapple will be 31 ounces. The alternative is that they won't be 31 ounces. And then also in the state, we want to mention what we're measuring here. So this would be the mean weight of all the pineapples grown in this field. And then we also want to mention the significance level, which would be 0.05. In the plan, I want to mention two things. One, what type of test it's going to be. This is a one sample t-test. Then I want to check the conditions. So they randomly selected 50 pineapples from their crop, so that condition's met. The normal condition, we don't know anything about the population distribution. However, since the sample size is more than 30, that's large enough for us to make it safe to use the T procedures that we're going to use here in the do part of this. And then the independence condition, we need to assume that there's at least 500 pineapples in their field since they took a random sample of 50. So the do part of this, I want to do two things. I want to compute the test statistic, which for this would be 2.762. And then I want to compute the p-value for this, which would be 0.008, and we'll talk about some different things with that in your calculator here in a moment. And then the conclusion for this, since the p-value is so small, we would have enough evidence to reject the null hypothesis, and what we would conclude here is that the mean weight of the pineapples in this year's crop is not 31 ounces. So if it's not 31 ounces, then what is it? Is it more than 31 ounces? Is the new crop less than 31 ounces? So before we answer that question, if I could just come back to the idea of the calculator and where these different values come from, the test statistic and the p-value for this. So if I sort of exit out of here and come back to the calculator. So with this, I want to do a t-test. So with this one here, I'm going to go to stats because they gave me a summary of the statistics for this. So the null hypothesis was that the pineapples weighed 31 ounces. In their random sample, the random sample came out to be 31.935. So I'm going to put that in here. The sample standard deviation for this was 2.394. So I'm going to put that in here. And then the sample size for this was 50. So I'm going to put that in here, and then we did a two-sided significance test for this, since it was not equal to. And so here, this will give me both the t-statistic 2.76 and the p-value 0.008. So just once again reviewing where that is in your calculator. So just keep in mind, and we talked about this with categorical data, when we make a conclusion with a two-sided test where we reject the null hypothesis, basically all we're saying that in this particular instance is that we don't believe the true mean weight is 31 ounces. So one of the things that we typically do with this type of situation is we follow up our conclusion with a confidence interval to say exactly how much we come up with an estimate for what we think the true mean weight is. So the confidence interval here, and I sort of gave you what these values were for this, and once again we'll talk about this in the calculator as well, but the confidence interval for this would be 31.255 to 32.616. So the conclusion for this, or we would follow this up in sort of the state plan do conclude, we would want to follow up with this here, and we would say that we are 95% confident that the interval from 31.255 to 32.616 captures the mean or the true mean weight of all the pineapples that were grown in this field. So just remember that the confidence interval that you compute is in direct relationship, or the type of confidence interval you compute is in direct relationship to the significance level. So if we do a 5% significance test, we would want to compute a 95% confidence interval. Whereas if, say, we did a 10% significance test, we would want to do a 90% confidence interval. So just keep in mind that those two values, the confidence level and the significance level, should always add up to be 100%. So with the confidence interval, and just kind of giving you the formulas here once again for the test statistic, and then this is the formula for the confidence interval, both of which are values that we could very easily compute in our calculator. So I want to kind of show you once again just the relationship there in your calculator with the significance level and rejecting the null hypothesis with the two-sided test and the confidence interval. So if I come back to my calculator, you can see here's the t-test where we rejected the null hypothesis. So if I follow this up with a one sample t-interval, which in your calculator is simply just called a t-interval, just once again notice the values from the problem will already be here, because when we do the two-sided test and we reject the null hypothesis, your calculator automatically assumes that you're going to compute a confidence interval to sort of follow up with your conclusion. So those numbers that I need, the sample mean, the sample standard deviation, the sample size, confidence level, that will all be there when I go to do the confidence interval for this. So I simply just have to go to calculate, and those are the values that you get for the t-interval. So that's basically it as far as just two-sided tests and confidence intervals and the relationship that they have when we reject the null hypothesis.